Hi guys, today we'll be looking at one of the question posted by my student. Basically, we'll be looking at the past year question from the year 2014, paper 2, question 4, H2 math syllabus, alright? Now, in this question, you're asked to present the complex number z which satisfy the equation modulus z plus 5 minus I equals to 4. Alright, now this is actually a circle, and what you should do is to just bracket, make this the difference between this local z and a point which is -5 plus I modulus 4, and what we will get is actually a circle with a center of -5 1 and a radius of 4. Okay, so how do I draw this? Try and draw to scale for your locus, so that when you're moving to the part 2, you'll be able to see how the perpendicular bisector is connected. Alright, please do refer to the question that I posted the link down in the comment sections below. Okay, refer to the blog because I will post the question there. Now, so drawing this shouldn't be a problem. Part 1 is not really a big issue for most of us. Draw it out. What you yield is basically a circle which 1, 2, 3, 4, 5. I'll use half a unit. 1, 2, 3, 4, 5. Here 5, -5 and 1. It's about 1 over here. 1 unit. So I'll use 2 units per cm, right? This is my center, and then this is my imaginary axis, and this is my real, and what I will get is basically 2 cm for 4 units. 2 cm for 4 units. So this over here. This circle. Alright, so this is my modulus z plus 5 -I equals to 4 with a radius of 4. Now, second part, this complex number z also satisfy this expression modulus z minus 6I equals to z plus 10 plus 4I. Right, now you're asked to find the exact possible value of z, giving the answer in the form of x plus iy. Okay, that's the question given. Now this is actually a perpendicular bisector from z to 6i and z to -10, -4i. So when you sketch this, just plot the 2 points, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 6 units. Alright, 6, this is your 6i, 1 point, and the other one would be -10, 4. So -10 would be 5 cm, -10, and 4, which is here, -4 is here. Alright, roughly about here. Okay, now then you're going to draw a perpendicular bisector of these 2 points, this line segment over here. So sketch, sketch, and over here, sketch and sketch. Okay, and you will get actually, oh, something is wrong. Did I draw wrongly? Here and 6i. Oh, I used the wrong scale. Goodness. Minus. Sorry, I'm just tired. Okay, so this should be from this point over here. Sketch, and I'll just sketch. Okay, and this perpendicular line, this is your bisector, right, within these 2 points. So over here, this is your locus of line perpendicular bisector. All right. Now, and you're asked to find the possible value of z. So is if z satisfies this and this, is basically the intersection, which is here and here. All right. So that is what I will try to explain, because I draw as 2 units per cm, so it may look a bit small. So I've already prepared the actual a bigger diagram so that I can explain. Right. Now, so given this diagram, how do we find these two intersection point, the coordinates over here? Okay. But so one thing that we can start off with always is to look at the radius. The radius is 4 units, right? All right. We start off with 4 units first, and what we want is this x coordinate and also the y coordinate. So we try and see what can we deduce from here. All right. Okay. So we know that this gradient multiplied with this gradient, it will give us -1 because it's perpendicular. Okay. But you can see from this is like somehow, if you draw the scale, looks like a 45 degrees, right, which is pi over 4. But just to be sure, you look at this, the rise is 10 units, 6 minus subtract -4, which is 10. Here is actually 10 units. So essentially the gradient here, the gradient is 1, and you can safely say that this gradient is -1, right? So if this is gradient -1, means the angle here is pi over 4, right? Because gradient is given by tangent theta. Basically, the theta is the angle subtended from the x-axis. Okay, pi over 4. If this is not okay, you can actually derive it from here as well, because here is 45 degrees. This is 45 degrees. Here alternate angle, here will be 45. Here these two angles are actually 90 degrees. All right, there are many ways you can derive from this. Now, then we would want to find this length over here. This length over here, by using your trigonometric ratio, your tuakaso, you'll get 4 cosine pi over 4 because it's adjacent. And here over here, you get 4 sine pi over 4, both of which will yield the same value, which this is 1 over root 2 or root 2 over 2, which will give you 2 root 2, right? Here we give you 2 root 2 as well, because this is root 2 and this is 2 root 2, right? So essentially, to find this coordinate over here, this x coordinate will be -5 minus 2 root 2. Am I right? Over here will be, this is what 1 unit up, because the center is -5 1. So this is 1, this is 1, this height here is 1 unit, and you add with a 2 root 2. So for this coordinate over here, we know it's actually -5 minus 2 root 2 and 1 plus 2 root 2. All right. So you do the same for the other intersection point. You will have over here, it's actually congruent triangles. Okay, these two triangles are the same. So because you have the same, this is what do you call this? The vertical opposite angles, which is pi over 4, and the radius are the same. So they are congruent, right? The hypotenuse is the same. So here, what we will get is same thing, 2 root 2. So for these coordinates over here, we can simply say -5 add with 2 to -5 add with 2 root 2 for the x coordinate, and 1 positive 1. For the y coordinate, we have 1 minus off with 2 root 2, right? So in this case, your two possible value of z, possible values of z would be -5, -2 root 2, plus I 1 plus 2 root 2, or -5 plus 2 root 2 plus I 1 minus 2 root 2. Sorry, okay, let me move up a bit. So these are your two answers for a part 2. Is that right? Okay. Thanks guys. If you have any questions or comments, please do leave your comments or feedback in the comment section below. Do visit my website www.elevelmath.org for more solutions, work solutions and videos that I make I try to make it on a weekly basis for my students from questions that posted by my students. Alright, thank you and have a great day. Good night.